Hello students, today's agenda is to check homework. We're going to learn about segments, angles, and rays, and you will be able to work on 9.2. Today students will be able to label segments, rays, and angles, identify collinear and non-collinear points, identify coplanar and non-coplanar points, and identify parallel and skew lines, and perpendicular as well. Okay, so take a minute to maybe pause it and then copy the agenda and the subat. So for the warm-up, I just want you to pause it, write it down, and try it before you see the answers. But it says, how many edges does a cube have? And then the second one is, how many vertices does a cylinder have? So if you recall, a cube is it's like a die with 6 sides, and so we can say that the cube has 12 edges. That's 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. Okay, how many vertices does a cylinder have? Some people had questions about what a cylinder is. This is a cylinder, and so the cylinder has no vertices, so none. Okay, so now let's start with the lesson, but I want you to recall from the previous lesson about line segments. So this is a line segment, and if you also recall, we can name it in 2 different ways. So you can say PQ, line segment PQ, and line segment QP. This is a line, not a line segment, a line, and you can name it line PQ or line QP. And so the reason for which I went back to this ones is because it's going to be very important to see what we cannot do with the ray. So what is a ray? This is the figure, and the definition says part of a line with one endpoint. And so basically in here we can find several rays. But before I go and label some for this ray and some rays from here, I'm gonna give you some real world connections that students came with during class. And so one real world connection, people said shooting star, because it begins from where it starts shooting, and then it continues and we don't know where it's gonna stop. So shooting star. They also mentioned sun rays, a propel car, rocket ship, and so it starts at one point and then continues, and we don't know where it's gonna end. Let me see if there are other interesting ones. Oh, one that they came up with was the life of a living person. Why? Because we know that their life started when either conceived or when they were born, and they are continuing with their life, and we don't know when it's gonna stop. Okay, so life of a living person. Okay, so now to label them, and I'm gonna use some colors here, especially for the second part, because that's, I know that some were getting confused. So, I have two here, so we'll see if we need more, then I'll look for some more. So, this ray is ray, look at the symbol compared to the ones right here, ray KL. And some people say, oh, we can switch them like we did with the line segment and the line over here. But in reality, we cannot say ray LK, because what this means is that the K is the initial, the beginning of that ray, and then it continues towards L. So the beginning is at point K, and then it continues that way towards L and past that. But in here it says it starts on L and then it continues past K. However, we don't see an arrow here, so that does not make sense. We cannot write that. We don't have a ray with that label. However, we can say, although not very often used or not used in many books, it's something like this. It means that the beginning is on K and then it continues towards L. Okay, again, this notation or label would not appear very often. Okay, this is the one that we use. Okay, so from this section right here, I want you to label some rays. Okay, if I say ray B, C, it means it begins on B and it continues towards C and past that. Another ray that we can see is AC. So it means it begins on A and it goes towards C, which is right here, and past that. That's what it means. Okay, so we also have ray BA. It begins on B, so you have to be very careful with this one. It starts on B and crosses A. So it begins on B and goes towards A and goes past that. Okay, begins on B, towards A, and past that. Okay, so that's this ray. And we also have ray, comma. We have ray C A. It begins on C and it goes past A. It begins on C and goes past A. We can also write, let's see, C A B A. Oh, that's it. That's the four that we can create in here. Okay. So remember, the first letter goes where the endpoint goes. Okay, and that just tells me, some people were confused because this was going to the left and they thought that they had to draw it to the left, but that's not what it is. It's the endpoint in here is aligned with the endpoint on this line to form only the ray that they're asking to label. Okay, the next one, the next figure is going to be angle. So you have one angle in here and you have several angles formed in the second figure for this section. And so the definition for angle is two rays with the same endpoint. So two rays with the same endpoint, which is called the vertex of the angle. We learned about vertices in the previous lesson, okay? It's where two lines meet, or it's one point where two lines meet. Okay, so let's start with the real world connection. Well, this looks like it's corners, right? Corners of anything in reality. It can be corners of shapes that are formed on tile, maybe, or maybe on windows. Um, if there are designs with two figures on fences. So basically any type of corner. But let me put some of those corners on the signs of tiles. For example, there are some tiles that have something like this, and then they have a line in there. So this is an angle right here. This is another angle. The corner of that square or tile is an angle. This is another angle. So there are different angles in a tile that is designed something like that. Somebody said corners in a frame or portrait, a picture. In the roof, I guess the tip of the roof, you know how it's shaped like that. Okay, so they were referring to this part. That's an angle. So tip of the roof. I guess the shape formed by the two parts that come together of the roof. They also said, let me see, corners in a room. So somebody else said, well, just any kind of corner, basically. Well, yeah, basically. Okay, how would you label this figure, this angle? So one name for this angle is angle B. You just use the vertex to name that angle, and that's enough. That will be a name or label for this angle. Another way to name it is angle ABC. ABC. Another one is CBA. CBA. So one important thing is that the vertex will always go in the middle. Okay, that's very, very important. And you use the other points in order so that you name that angle. Okay. Now I asked, so when I say, okay, label or give me the name of the angle in here, can I say there is an angle O, like I did in here? And some people said yes. And I said, okay, which one is angle O? And if you think about it, this O is this point, this vertex. This vertex is the vertex for this angle, 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 for this angle. So basically we cannot use only one letter like we did in here. We have to use 3 letters to name each angle. And for example, if we want to label this angle, then we would say angle BOC or angle COB. BOC, COB. Remember that the vertex is always in the middle. Okay, what about this angle right here? Can you name it before I give you the answer? Okay, so it will be angle COD or angle DOC. Okay, I'm gonna label some more, but I'm not gonna do all of them. In here, for this one, it would be angle DOE or angle EOD. Okay. For this one, the name or label will be angle EOF or angle FOE. I think I'll do one more, or just do all of them since it's almost there, right? Angle FOA or angle AOF. And I'll do the last one, this one right here. That will be angle AOB or angle BOA. Okay, now I'm going to ask you to pause the video and copy this shape. And now that you have it, hopefully, and if not, again, pause it and copy it. We're going to learn about collinear points and non-collinear points, coplanar points and non-coplanar points. And so collinear points are points that lie on the same line. Okay? And if we have 2 points, it doesn't matter where they are, they will always be collinear. Okay? Now, some real world connections are, and these are again examples that my students have come up with, houses on a street, collinear on the same line, right? So let me draw the figure. It will look something like this. Again, it can be at least 2 points or more. So the points on the same line, houses on a street. I heard also Christmas lights. Kids lined up also. Cars on a street, or even if they're parked, parallel parked, they will be collinear. And labels, you wouldn't, so this one we can just discard that because basically it would be just points. If they ask you for points, I guess we can just say if this is A, B, C, D, you could just say give me 3 points that are collinear. You can just choose any of the 3 in here. So, and you do put commas because you're talking about the points, not the line, but the points. Okay, so those 3 are collinear. You can also say that letter D is collinear. So from this right here, which ones are collinear? Well, we have all of these 3 on the same line, although they can, if I have a, let me see, maybe this one is also collinear. Almost. If this was a little lower, even though this is on the line, but these are not, but they're coplanar, they're on the same plane, and they were aligned. If they were aligned, they will be collinear. So we cannot say that because this one is a little bit higher. But definitely BOA are collinear points for this figure right here. Okay, what about non-collinear points? Non-collinear points are points that do not lie on the same line. And so I'm not going to give real world connections, but it's just when kids are playing around, or when you throw marbles and they're spread around, they're not forming a perfect line. So maybe I should write them. Spread marbles, or kids on the playground, because they're not on the same line, they're all over the place. Okay, so non-collinear points in here, maybe you can say Q, P, and A, because A is kind of like pointing up outside of the paper, if we pretend that this is a paper. So non-collinear points examples would be Q, P, A, right? As long as one is out of the line, we can say that they're not non-collinear. Okay, let me see how am I gonna do it for this one. I guess I'll go back and forth. So coplanar points are points that lie on the same plane. We're talking about the plane now. And so if we go back here, what would be some of the points that lie on the same plane? Well, on this plane, plane M, points that are there are R, O, P, and Q. So R, O, and some examples are, for example, if you're on a field, on a like baseball field, you have people all around it. Those will be people on a field, soccer field maybe. They're on the same level. But now if you're talking about a person that is on the field, and then some people are on the benches watching the game, so those will be non-collinear examples. Non-collinear, non-coplanar. Okay, so non-coplanar points that do not lie on the same plane. Okay, so people, so some people on the field and some on the benches. Okay, and even more because the benches are some different levels, so you could say that the points are on different planes. Okay, so what are some examples of non-coplanar points from this figure that are not, as long as one of them is not on the same plane, we can just, for example, we can say Q and P with B, for example, and this being outside of this plane makes it non-coplanar. Okay, so let's put those, let's put R, Q, B. Okay, and there are other groups of non-coplanar points, but we're gonna leave it with this example. Okay, if you can think of more, you can add more in here, but it's a good idea to just see that it's on the same. Like we can also have on a table, we can have different spoons. Those would be coplanar. Okay, but then if we have spoons on the shelf, and then one on the floor that fell, and maybe one on top of like a pot or something, then they are on different levels, and we can say those are non-coplanar. Okay, so spoons on the table, and then in here we can say spoons on the floor, shelves, sink, the table. Okay, so they're all over in different planes, so that will be non-coplanar points. Okay, now let's go back to the box, and if you can take a minute to copy it. And with that box, we're going to learn about parallel lines, skew lines, and perpendicular lines. So pause it right now so that you can copy the box, and then pause it so that you can also copy this part. And so I'm gonna move to the third one. So you already paused it and copied it, right? And then finally this one, so pause it. Okay, so now I hope that you have all of them. And okay, so let's start with parallel lines. And again, I like to give you the shape and also the definition, but I like when you come and think of the real world connections before we go ahead and label some of them in here. So what is a real world connection for parallel lines? People told me about rows in a field for when they're oh my goodness, when they're farming or growing corn, for example, or trees, or they always put it in parallel lines. Okay, so rows of growing crops. For example, corn. They also mentioned strawberries, etc. They also said cherry trees. Okay. Another example is the lines where the airplanes come in. So in the airport, I guess lanes where airplanes take off. And they also said lines of streets. And opposite sides of a frame. Okay, so these are just some examples of parallel lines. And so to label in here, so we know that lines, parallel lines are lines on the same plane that do not touch. And so if we think of this box, which lines are not gonna touch? Well, we have one in here. AD will never touch with EG, and they are on the same plane. So the symbol that we use is AD, line segment AD is parallel. This is the symbol to mean parallel, is parallel to line segment EG. Another pair of parallel lines is, for example, this one and this one are on the same plane and will never touch. The same for this one and this one are a pair of parallel lines. Maybe I should label them with different colors. So this is a pair. This is another pair. Okay, of parallel lines. So AE is parallel to BF. DG is parallel to CH. We also have DC is parallel to GH. AB is parallel to EF. So I'm not gonna write all of them. I'll write some more, but I hope you're getting the idea here. And then BC is parallel to AD, and if you think about it, AD is parallel to EG. Okay, and EG is parallel to FH. So you're gonna ask, why did she color all of these ones blue? Again, these are pair of parallel lines because they're on the same plane. These are parallel lines because they're on the same plane on top. FH is parallel to BC because they're on the plane in the back. So there are different combinations in here that we can make. Okay, I'll just write one more. I'll write this one, DG is parallel to, or DG to CH. Okay. Now let's go, and I think I'm gonna have to cut this. Yeah, I'll do that. Very fancy here. And the reason is because we're gonna need this we're gonna need to see it. Okay, so the next is skew lines, and skew lines are lines that are not on the same plane but do not touch. And I use the word skew so that in Spanish we can remember it. It's like esquivar, lines that try to avoid each other. And if you think about it, if we have one in here but it's towards the front, and then maybe, and that will be DG. Okay, I'm gonna, oh, the color that I use for DG is green, so DG. And we don't have a symbol for skew lines, so we're just gonna say which ones are skew. So DG, and let's see one good example. So DG is up to the front on the box, and BC is going sideways, but it's also on the back. Okay, so if you think about it, it will look something like this. If it was a box, it will look something like this. Okay, so they will never touch, and they're not on the same plane. This is on the front, this is in the back, and this one is going up and down, and this one is going sideways. So, and BC. So DG and BC are skew lines. Let me see. Another pair of skew lines is DC and BF. It's in the back, right? BF is in the back and up and down, and DC is on the right side. So it's kind of like this if we were looking at it in a different position, but they will never touch if you extend them. Okay, this will extend up and down in the back. This will extend sideways, I mean to the front and back on the right side. So that's gonna be AB and which one did I say? Oops, DG maybe? I don't know. Okay, so that's another pair of skew lines. Maybe this one, it's in the bottom, and then we have this, even any of these actually, it's gonna go up and down and will never meet with this one, okay? Because this one is kind of like going to the front and back, and these ones are going back and down and very separate. Okay, real world connections. I don't know. You can think of just some of the sides of the boxes, but it will be hard to describe. So just like I was describing it here with words, I'm not gonna ask you to describe something like this, like the skew lines connected to real life. Okay. Now let's go to perpendicular lines. The definition for perpendicular lines are lines that intersect to form 90-degree angles. And you have some drawings in here. You can just form an L, or you can form the whole 4 angles. And all 4 angles are actually 90 degrees. Okay, so real life connections could be tables and legs. Well, the table and the leg, okay, because the table is like this, and then the leg is like this, and so it's forming a 90-degree angle. Okay. What else? Corners can also form 90-degree angles. So corners in a room, those will be 90-degree perpendicular. So the walls, basically, opposite walls, not opposite walls, adjacent walls to next to each other, and then they would be perpendicular. And maybe streets, for example, crossing streets that are going exactly, so maybe there's one in here and then there is another one, so crossing streets. Now notice that not all of them form exactly 90-degree angles, so not all of them will be perpendicular to each other. Okay, railroad also, you have the railroad and they are always aligned. They form 90 degrees, so rails in a railroad. Okay. Okay, so those are real life connections. If we go back to this figure, the way that you label them is, for example, we're saying that these two are perpendicular. We say DG is perpendicular to line segment EG. Or another pair would be DC, line segment DC is perpendicular, so the symbol is an upside down T, basically, and if you notice, it forms right angles in there. Oh, letter T also would be a real life word problem, real life word connection. Letter T, letter L, letter H, right? If for this line with this one form 90-degree angles. Okay, so several of the letters are perpendicular lines, form perpendicular lines. Oh, sorry. So DC forms a right angle with CH, line segment CH. Let me do one more. AB. So line segment AB is perpendicular to BF. Okay, and there are many others that you can form in here, but we'll put only those. And with this, our lesson concludes. It's kind of long. I'm so sorry. So many definitions, but I hope you can now do 9.2.